Okay, so now we're moving on to 2.3, deductive reasonings. Okay, we've got a little bit of new vocabulary, but not much, but we've got deductive reasoning, which is going to come up. Now, in 2.1, you learnt about inductive reasoning, which is a pattern that you get from examples. So, for instance, you were looking at numbers or time or different shapes, etc. Well, deductive reasonings is you're looking at data, you're looking at facts, you're looking at figures and things like that. How can you come to a conclusion, a logical conclusion to say it's right? And as you can see from the diagram, you know, think of the police and the detectives. They will do a lot of soul searching and fingerprints and finding statements of people, and eventually they'll come to a deductive reasoning whether or somebody is part of the inquiry or even guilty. Okay. So let's have a look at number one. So number one is, example one is either you're going to be inductive, which is facts and figures, or it's going to be deductive, looking at rules, etc., etc. Okay, so example 1A says that every time Lauren has a healthy meal before her run, she is able to run faster than her sister, okay, who does not like healthy food. Lauren has eaten a healthy meal so she concludes that she will run further than her sister. Okay, is that inductive or is that deductive? Well, because it's a pattern of behaviour, if she eats healthily, she runs faster than her sister. So as you can see, that is inductive reasoning. Okay, but B is if John is late making his car insurance, he will be assessed a late fee, etc., etc. So he concludes that he will be assessed a late fee because he's late this month. That's based on the facts that the insurance company come up with. So that's deductive reasoning. So how does that fit into questions like this? Well, let's have a look at number one. It says students at Olivia's high school must have a B average in order to participate in sports. Olivia has a B average, so she concludes that she can participate in sports. Okay, well that's deductive, okay, because obviously you've got to work on the facts that that's what the school decides through their rules and regulations. So that's deductive reasoning. So let's have a look at the law of detachment, which is the next one on the list. Okay, it's if the statements are true, then if the hypothesis is true, then the statement should be true and vice versa. So here's a perfect example. If a car is out of gas, it will not start. And then obviously the statement is Sarah's car is out of gas. So you can make that valid conclusion that if her car is out of gas, it will not start. Yes, there may be other reasons, but we're just looking at what is given in the question, which is that she's got no gas. So here's an example of it being used. Okay, if two angles form a linear pair, which is what AEB does and AED, then their non-common sides, which in this case is going to be BE and ED, they are opposite rays. Okay, so going right the way back to questions in statements in the first chapter, look, we're looking at the arrows, so it makes a line, they're going in opposite direction, they have to be a linear pair. Okay, so let's have a look at what you've got to do first. Right, you've got to determine whether the stated conclusion is valid based on the given information, and don't forget, valid is it's true, invalid is it's false. Okay, so and then we're going to use the law of deduction at the same time. So it said if a number is divisible by 4, then the number is divisible by 2. We know that because 2 goes into 4 and every multiple of 4. Well, 12 is divisible by 4. So there's the statement. The conclusion is, well, if 12 is divisible by 4, then it has to be divisible by 2, and that's a valid statement, okay, because we do know that 12 is divided by 2, and explain your reason. It's the law of detachment. Okay. So make sure that you put everything down that you need. Okay, it says you've got to write whether it's valid or not and explain. So it's valid and it's the law of detachment. Okay, so now we're going to do exactly the law of detachments, but this time we're going to put it in Venn diagrams. Okay, we don't do many Venn diagrams in geometry, but occasionally we do. All right, well, let's have a look at the statement. It says if a primate is an ape, then it does not have a tail. Coco is a primate who does not have a tail, so you can ignore the little bit in the middle. So if Coco is an ape, then if Coco does not have a tail, then Coco must be an ape. Okay, so there's using the law of detachment. Okay, so keep it simple. Okay, you've got primates that are apes and primates that are with tails. Well, we know that Coco is an ape, so it must go in this little box because she's got no tails. All right, so make things as simple as you can as far as Venn diagrams are concerned. All right, so let's have a look at number 5. Okay, it says determine whether the stated conclusion is valid based on the information, if not right, invalid, and explain your reasoning with a Venn diagram. Okay, so have a look at number 5. If a beach is public, then it does not have a lifeguard. Bayview does not have a lifeguard, so from that information, Bayview has to be a public beach. So for number 5, that's valid. Okay, so now let's draw your diagram, and it's not too different to the Coco and her so here's beaches. Okay, and then inside you've got public and you've got lifeguard. Okay, I'm going to just abbreviate it. Right, so where does it go? Well, obviously, if we look at what we've got, we know that Bayview is a beach, so we really need a point in there. But because it does not have a lifeguard, it's also a public beach, so it goes in there as well as. Okay, so now let's have a look at the law of syllogism. Okay, the law is another form of deductive reasoning. The law allows you to draw a conclusion from, so if you've got two true statements, then the conclusion of one statement is the hypothesis of the other. Okay, so if you are an actor, then you enjoy musicals. There's the conclusion of the first one, and it becomes the hypothesis of the second one. Okay, if you enjoy musicals, then you enjoy theatre productions. Okay, so basically two statements, both of them have got the same wording, and all you can do is basically miss those out. All right, in some respects you can just turn around and say, so in other words, if you found out that one is the conclusion of one true statement and then the hypothesis of the other statement, basically these two guys cancel out, and what you're left with is your final statement. And as you can see from your final statement is, if you are an actor, then you enjoy theatre production. So basically you miss out that middle section. Okay, so let's have a look at what we've got to do here. You've been given two statements. If a triangle is a right triangle, then it has an angle that measures 90. If a triangle has an angle that measures 90, then its acute angles are complementary. So going back to what we've just said, here's the conclusion of the first statement, and here is the hypothesis of the second statement. So basically what we can do is just ignore those two, and they should fit and do it as a statement as itself. So in theory, if I'm looking at question 7, I should be able to just write, if a triangle is a right triangle, then its acute angles are complementary. Okay, is it valid or is it invalid? Well, let's have a look at number 7. Number 7 is not purely, so this is invalid. Oops, let me just delete that and start that bit again. That wasn't very good, but yeah. All right, so basically it's invalid. And why is it invalid? Even though it's using the same wording, it has to be in order. So this bit must come first and this bit must come second. Well, in question 7, 2 comes first and 1 comes second. So that is invalid. Because of that reason, it doesn't follow the law of syllogism. Okay, so now you've got to use the law of deductive reasoning. Okay, so you've had the law of syllogism and the law of detachment. Now you've got to work out, with using either or of those, can you come up with a valid conclusion? Okay, so given that if you are 16 years old, then you can apply for a driving license. Nate is 16 years old, so we know that we are 16 years old. We know that you can apply for a driving license, so we know that that's okay. So as far as that is concerned, Nate, bless him, can apply for a driving license. All right, so let's have a look at number 10. Draw a valid conclusion from the given statements. If possible, then state whether your conclusions were drawn using either the law of detachment or the law of syllogism. Okay, don't forget, one of them fits, one of them doesn't. Well, let's have a look at what you're given. If Delilah finishes her chores, she will receive her allowance. If Delilah receives her allowance, she will buy a shirt. Well, there's no connection between one or the other as far as that they've got the same conclusion and statement. So therefore that this is the law of syllogism, okay, because they don't follow deductive reasoning. Okay, so it's the law of syllogism, but from the fact that if she refuses, so if it works out, she can buy a shirt, a new shirt, okay, but she can only do that from the fact of law of syllogism, because we don't know whether or not she did complete her chores.